at. This is the payment system broadcast session 17, in which we're going to discuss anomaly detection in payment systems, findings and implications. We're going to allow the attendees to join for a couple of seconds, and then we're going to start. Good. In the meantime, the agenda for today is, it will be a little different than usual, in the sense that we're going to have a very interesting presentation by our co-speakers, because we're going to deal with a document that has a lot of very interesting findings. So we're going to change the layout of our broadcast slightly. So what we're going to have is, as usual, the introduction and housekeeping for 5 minutes from myself. Then we're going to have a main session in which we're not going to have like this usual exchange of questions and answers with the co-speakers, but we're going to have like a presentation, and then we're going to have question and answers from the moderator, myself, and also from the public. So this is going to be a slight change from our usual layout. Next, so to introduce the topic, which I already mentioned, that it's anomaly detection in payment systems, most specifically in large value payment systems, we're going to have together today Anneke Kosse from the which is a senior economist at the BIS in the Secretariat, supporting the Committee of Payments and Market Infrastructures of the BIS. And we're going also to have Ajit Desai, Principal Data Scientist of Bank of Canada. He's a Principal Data Scientist in the Research Division at the Bank of Canada's Banking and Payments Department. So thank you both for joining us today. And as usual, and because we have Ajit from Central Bank, and also Anneke is from the BIS, I would like you to introduce yourselves and also to give all the disclaimers that you deem appropriate for our occasion. Afterwards, we're going to start. So I don't know who wants to jump first. Anneke, Ajit?
Anneke, go ahead.
Okay, good. Well, welcome everyone, and thank you, Carlos, for having us. I think it's really a pleasure to speak here and to also really share the work that we've done on this topic. Indeed, I am a senior economist at the Secretariat of the CPMI, which is the Committee on Payments and Market Infrastructures. And the work that I'm doing is basically combining research and policy work, focusing on trends in payments, and especially from the digital innovation perspective. Looking into the risks of that and trying to understand where the landscape, where we're actually heading to. Yeah, so let me stop there.
Yeah, likewise, it is a pleasure to be here, and thank you, Carlos, for having us today. And it's also FNA for providing such an engaging platform to discuss all the payment-related issue. So I'm a principal data scientist at the Banking and Payments Research team at the bank, where I mostly work with other economists. I come from the technology background, but I work with the other economists like Anneke, where we try to focus on the two aspects: how to make payment system more efficient by making use of the advanced technology, and also how to make them safer by using AI, machine learning. And we recently started venturing into, is there a scope of quantum computing in this area? So I'll stop there.
That's great, Ajit and Anneke. Perhaps the best way for me to introduce and to let our co-speakers start with their presentation is to highlight that normally when we talk about in this payment systems broadcast, when we talk about fraud, scams, anomaly detection, and so on, it's about retail payments. So it's credit cards, it's retail transactions, it's some other type of transactions. So it's very interesting to have In this case, something which is related to anomaly detection in large value payment systems or in RTGS systems. So that's something which we find very interesting. And I think that several central banks and obviously overseers and supervisors of financial market infrastructures will find interesting, very interesting. So the floor is yours, Anneke and Ajit. Let's start.
Thank you so much. So let me ask Tasha, maybe you can show the slides. And actually, the first slide, as you're popping it up, is actually about the motivation. Actually, before I really start, I also need to remind you that the usual disclaimer applies. So all the views that we are sharing here, everything that we say here, is not necessarily the view of the Bank of Canada, nor that of the BIS, the Bank of International Settlement, or the member central bank. So it's really the views of Ajit and myself. So next slide, please. The motivation. So really, what got us sort of looking into this question, and indeed, the question of and the focus of large value payment systems. So remember, large value payment systems. They are really, we see them as the core of a country's financial infrastructure. Large value payment systems, which we here abbreviate with LVPS, they're really the systems that behind the scenes process all these large value, in most times also critical payments between financial institutions and also ancillary systems like security settlement systems, maybe exchanges. So large value payment systems are really crucial for the functioning of an entire economy, which also means that the safety, the robustness, the efficiency of large value payment systems is really key for financial stability more generally and economic growth more generally. At the same time, we also realize that large value payment systems, they actually serve as a link between financial institutions. They're like the spider in the center of the web. So if not properly managed, large value payment systems, they themselves can become a channel through which like shocks or events at a participant can actually transmit to others domestically, but also internationally. So that's why we really thought about, okay, let's have a look at the system and let's think about like the monitoring of activity in a system, in a payment system at the system level. And especially also in view of the latest trends around like cyber. So we've really seen an increase in the number of cyber attacks on financial institutions, but also on payment systems. So, and then we really think that if these attacks, but also other types of stress, like market stress or payment fraud, operational issues, events like that, if they are left sort of undetected, again, through this position of the system being the spider in the web, events like that can actually broadly impact, or generally and pretty quickly impact others in the entire system. Now that we know that, and that's also the case in the retail payments, we know that individual financial systems of institutions, they have their own tools and they already do a great job they already do a lot to monitor transactions. But these really only capture transactions to that in participant or transactions among clients of that particular participant. So their monitoring tools really lack a system-wide view. And that's why really we started thinking about, like, is there a way that we can monitor transactions on a real-time basis, but at the system level? So next slide, please. So yeah, when we really started thinking about that question, we pretty soon realized that it's not an easy question. There's quite some challenges. There's quite some challenges if you really want to monitor transactions at a system level. And why is that? So I'm actually summarizing here a couple of key causes. First, payment networks are often very large in terms of the number of participants, the diversity of the participants. I mean, these are not only large banks, can also be small banks, can also be non-banks, can also be ancillary systems. each being very different in terms of behavior. And altogether, there's a high frequency of payments among them or by them. Secondly, payment behavior in large value payment systems is, I think it's pretty complex because of the sort of strategic nature of this behavior. And for example, a common trade-off that is often faced by participants when they decide when to pay something or how much to pay and who to pay to, at what point of time in a day, for example, the trade-off that they face is between the speed of the payment, but also the liquidity costs. So payment behavior, payment patterns in large value payments systems, they often exhibit like a certain level of payment coordination between participants, really with the aim to maximize, for example, netting opportunities or to minimize liquidity costs. So all these strategic behaviors come also into play, which also make it more challenging to monitor unusual behavior. Another challenge is that most of the payments that are observed in a payment system or that are made by participants are just usual transactions. They might be big in some cases, but there's nothing wrong with them. And that's the thing, like most of the payments, it's just fine. The anomalous payments are only rare. And they're not only rare, they're also not labeled. So it's really difficult to find them. It's really like the title of the paper says, it's really about finding a needle in a haystack. And that's why what you see today, many of these tools, detection tools that are used by payment systems, but also by individual participants, usually are based on preset rules. So preset rules that are based on assumptions of how an anomaly might look like. For example, a flag may be raised if a participant X, for example, makes a payment after 3 p.m., which is higher than a certain amount. I mean, you can program these rules, and then of course some lights can be shut on if the rule is satisfied, for example. But it's all based on preset rules, and of course it's impossible to anticipate all potential scenarios or all potential forms of anomalies. So that's why we came up with this new approach. The next slide, please. That's actually presenting the paper. Yeah, so this is the paper in which we present this new model. And next slide, please. Yes, thank you. This is basically, well, how it works. In very short, in this paper, what we did, we developed a layered machine learning framework that can be used for two things, basically, both for pattern recognition, so recognizing payment behavior of system participants, and for anomaly detection. And very high level, the two layers that we have, or the layers that we have, the first layer consists of a payments classifier, which is the red thing in the middle of the slide here. What this payments classifier is basically doing, it's a supervised machine learning algorithm that classifies payments in large value payment systems based on the time of the submission into the system. Now, this classifier, what it does, it separates correctly, so it classifies payments and then separates the correctly classified payments, which we call the usual transactions, from the misclassified, the unusual transactions. And then in the second layer, what it does, it only focuses on these unusual transactions, or the misclassified transactions, and it takes that subset and then processes these through a sort of unsupervised machine learning algorithm to detect anomalies. So in short, I think the key strengths of this approach is that first, by filtering, by separating the usual from the unusual transactions, we narrow down the total number of transactions that will be checked for anomalies. So it really makes it easier, a much easier task to do so. So we narrow down the total scope of transactions that need to be checked. Secondly, by using machine learning algorithms, there's no need anymore to come up with prior assumptions or to have to come up with prior preset rules of how an anomaly might look like. And this increases the performance and eventually the likelihood of catching anomalies. proper anomalies. So let me stop here. So this was a high-level overview of the why and the high-level what. And let me give the floor to Ajit for some further details on this framework and the algorithms. Ajit.
Yeah, thank you, Anneke. So just before we move on to the next slide, I just wanted to add, like in this layer approach, we have three modules, I would say. Pre-processing module, where we take all the data which is coming from the payment system as a settled data, and then we extract a lot of features from that data set. So generally, payments data has a way, especially in the high-value payment system case, is not as rich as the retail payments data. So we have a few features, like which participant is initiating the payment, to whom they are sending the payment, what was the amount, what was the type of a payment in terms of the SWIFT code, and what was the time it was submitted to the system. So we realized that just using those few features is not enough. So if you can move to the next slide. So that's where we say the pre-processing module, where we extract a lot of features. So the basic transaction feature, as I said, has a sender, receiver, payments type, amount, and the timestamp. But there are some other features. For example, high-value payment systems are not like retail payment system in a sense. Every payment you make, you have to have a liquidity provided by the central bank when you pledge the collateral. So we extracted that information from the collateral management part of the high-value payment system. That essentially gives them the credit limit, and that credit limit goes up when they receive the payments, and that goes down when they send the payments. On top of that, we also try to extract these seasonality features, which is extracted from the timestamps features of the transaction. So as Anneke pointed out earlier, that many of these transactions are usual. So some of these transactions are so usual that you can expect that this kind of transaction will be coming on this day of the week at this time of the day. So we try to extract those seasonality feature and use them so that our model can learn that if this participant is sending this type of transaction to this particular participants on this time of the day, then it should be okay. On top of that, we also extracted a lot of intraday features, and that's where we took some motivation from the retail payments fraud detection literature. So here we try to extract the relations between the consecutive transaction. So before a participant submit a transaction, what happened into the system? Did that participant receive any payment which invoked the submission of this payment? Because as I said, this is more like a closed system with every participants are linked to each other. So my credit limit goes down as soon as I send my payment, and it goes up as I receive the payment, so that I can recycle. So maybe my action is driven by something just happened before into the system. So we try to extract the temporal dimension, like when did this particular participant receive another payment from any other participant from the system, or the same participant to whom he is sending the payments, because there is also strong bilateral relations these participants have into the system. And we thought that in order to exploit this usual behavior, those kind of features might be very useful. So if you go to the next slide. So I'm just not going to go into the technical details. I'm just going to give a big overview, or the high-level overview of the two layers of the payment system of our framework. So in the first layer, we, as Anneke mentioned, that we have this payments classifier. It essentially tries to classify the payments based on the historical data into number of classes. So here, for an example, we are showing two classes, morning or afternoon. So for a given transaction, we know in the historical sense that when that transaction came into the system, whether it came into the morning period between 6 to 12 or afternoon period. Of course, this is just an arbitrary representation. You can have more classes, and you can also have a continuous target there. And then we use all the payments features we extracted or we discussed in the previous slide as a part of the input, and then try to map them to the period of the payment or the timing of the payment. And essentially, this model is learning that given these are the features of the payments, whether it should be coming into the morning or coming into the afternoon into the system. So that's our payments classifier. And all the payments which are correctly classified this payment, which is our objective, is to learn the usual behavior in the system, which is more prominent in high-value payment system, and then just isolate or separate the payments which are not this model thinks are not usual. So, and then look at those only subset of those payments in the second layer. So if you go to the next slide. So as we said, like in the first layer, we isolate and separate most of the payments which are our model thinks as a usual, and in the second layer we take the subset of the payment which is being misclassified by the model, and then we operate another machine learning model which is more unsupervised. So we are not putting any target here. So essentially we are using model called isolation forest. So this is a decision tree based model. And essentially the number of splits on the number of splits you need to separate a transaction from the rest of the transaction, it defines how anomalous it is. So for an example, I have this plot here where on the x-axis we have the payments timing and the y-axis we have this payments amount. And as you can see that blue dot and red dot, although the timing of the payments are about same, the value or the amount which is being submitted in this particular transaction is very different. So for isolation forest or any of this tree-based model, it's very easy to isolate that red dot from rest of the blue dots or green dot. But if you want to isolate or separate that blue dot, you need a tree which has more splits, which requires more splits. So essentially, just for demonstration, to isolate that green dot, we need about 6 splits so that the anomaly score of that dot is very low as compared to the red dot, which is very easy to isolate just by using one split. And you don't do it once, you do it many times using different tree, and then you take the average score so that you focus on the robustness of the model. So that's what the second layer is, and then it assigns the score to each of these transactions. So if you go into the next slide. So I will not go into the details. We can have more discussion in the question and answer, but essentially we took 10 years of data, we extracted all the features from that data. But what we try to do, given we don't have a labeled example, we try to identify some of the known anomalies or known unusual behavior that is happened because there is a provincial holiday in Canada, or there is a US holiday that influenced the financial transaction that happening into the high-value payment system in Canada, or there is a financial like end of the quarter and those types. So we separate those days because our objective is to learn as accurately as possible the usual behavior. So we look at the days which are more usual, in a sense we don't have any label unusual transaction into them. And then we train our model and then try to test it on some of those unusual days and also some of the artificially generated anomalies. So if you go to the next slide, please. So here we have the results of how accurately models are performing. So on the left side, we have this chart, bar chart. So each of the bar, shows on the y-axis the percentage of the misclassified payments. So smaller the percentage of the misclassified payments, that means model is learning a usual behavior. But whenever there is a unusual day, so these are the special days which we have already identified into the system, such as the operational incident day, partial holiday, and so on and so forth, including the COVID-19 period, which has some implication on the high value payment system liquidity management. So there were change in behavior. So on those special day and on the COVID-19 period, our model misclassifies a lot of payments, suggesting that a lot of these payments are not happening the way they used to happen into the system. And when we use this artificially generated anomalous sample, model thinks almost 93% of those payments are being unusual, that they shouldn't be happening in this manner. So that shows us that like a model is learn what used to be generally used to happen. And if it is happening some certain different way, then model just misclassify those payments. So if you go to the next slide. Yeah, so in this case, on the next layer where we use the isolation forest, we try to see as soon as we make the transaction anomalous by artificially manipulating some of the feature, the anomaly score, which is captured by the number of splits you need to isolate given point, goes up. And in the right direction, in a sense that model thinks that, okay, this is more anomalous than the other payments, subset of payments. So on average, the subset of artificial anomalous payments, the anomaly score is almost double than the subset of the usual payments. So in the next slide, I think we have one example and then we'll wrap up. So here, again, we need, if you're just isolating this anomaly, but you don't provide any information, it's very hard to interpret why this transaction is being classified as anomalous. So we try to use another, as a post-processing tool, another framework based on the Shapley values, which is motivated from the game theory economics. So here we took the real transaction, which is on the top, and the model thinks that that is a model correctly classified that transaction, that sender 6 is sending that transaction to the receiver 7 at this time. So I'm not going to the detail, but the low negative scores means that it's a morning period, and the high positive scores means our afternoon period. So we manipulate that transaction, and we know which features we manipulated in that. So in the second plot below that, that model thinks now this transaction is afternoon, and it misclassifies that. And the main reason that is being this red arrows, so period time. So we specifically manipulated the period time such a way that generally this participant doesn't send that large value payment into the morning period, but they send it into afternoon. So as soon as we change the period, model thinks that no, this is something wrong. So these are the tools we can use to assess the quality of the model, and it can be useful for the payments operator to understand why this model thinks in this way, and it can help them to navigate whether it is a true anomaly or it's just something that sometimes happens. So if you go into the last slide. Yeah, so I think Anneke has emphasized these pointers earlier. So essentially, it's a centralized in a sense we can able to see the data from all the participants, as opposed to if it is individual where participants can see their own data. So we might able to capture different types of pattern as opposed to individual participants. And the layered approach is essentially to come up with this challenge of a lot of data which is usual, and there are few anomalies and which are not labeled. So this going step by step can help us. And another thing which didn't pointed out in the presentation, but our layer approach is also flexible in a sense. You can have multiple models in each layer to increase the robustness. So we are just using this binary classifier for demonstration, but you can have another binary classifier which is not learning based on the timing of the payment, maybe the payment's type or something else. And of course, all the models we are using are nonlinear, so they can help us to capture these complex patterns. And I think that's the last point. It is adaptable, so we can adapt it to the different types of payment system. You can have more features or more target variables and more models. So it's a very flexible framework. So I think we'll stop there and we can have more question and answers.
Okay, that was a great and quick presentation indeed. Thank you very much for all the content, because it's very interesting. And you can see, I mean, you, Anneke, and Ajit, that there have been several questions and that have been raised by several of our attendees. So we're going to have a very rich conversation from now on. I'm going to start with my questions, which in fact have a lot to do with the questions that the attendees have sent. So I'm going to start perhaps with the one which is I think it has been repeated a couple of times now, which is and in fact, I want to introduce that at FNA we're working with a central bank also in an anomaly detection in their RTGS system. I'm not going to reveal the name so far, but one of the main challenges that we have found out while developing and implementing this anomaly detection is how to balance false positives and true positives. Especially because obviously when you have the staff of a central bank of the payment systems, and they have to start reviewing transactions to have a lot of false positives. Obviously, it's it becomes cumbersome for the staff to check. Is there any lesson that you could share with us about how the false positives and true positives can be balanced, and how the staff can work on the results for like taking action? Because at the end, this is about taking action from a central bank perspective or our operator perspective.
Maybe I can quickly go on. Anneke, if you need to add something, feel free to. So I think that is the problem of most of the machine learning model. I want to be upfront about that. Like it is the problem of most machine learning model where there are a lot of false positives. But having this multi-layer approach, I think can help us to alleviate some of those challenges at least a bit. So let me put you first give an analogy which maybe help us to discuss this further. So this two-layer approach is kind of in a very high level similar to the airport security screening process, where let's say in the first layer, you initial security checkpoint where you have your bags or passenger pass through the metal detectors and body scanners. And this essentially help us to filter out most of the usual part of the process so that you don't have to look at most of this transaction manually or most of these passengers or bags manually, but the only which has been flagged by the first layer, automated layer, then you can spend more time on the second layer or in the second step where they can check the bag manually or they can check the people manually. So it's in a sense they're trying to reduce the workload of these operational people which are on there. So so what I was trying to say here is like our two-layer approach. First of all, try to reduce the number of false positive. In a sense, they are trying to take it out of the system itself so that your model doesn't have those kind of have less of those sample in the data. And in the second layer, where we have this anomaly isolation forest, which can assigns the anomaly score to each of these transaction, but it not necessarily just assign the anomaly score. It is in a quantitative way. You can sort those transactions from very high anomaly to low anomaly. So imagine you have a situation where payment system operator can at a time check 10 transactions, for example. So but there could be a lot of false positive, but false positive might be for lower anomaly scores. So you can focus on the transaction which has a very high anomaly score, so that you are using the attention and the energy you have to try to catch some of this key transaction, as opposed to trying to look at the big set of subset of transaction. So I don't know, it's a vague explanation that it is one of the way we think our model can alleviate this, but I'm open to debate on that.
Okay, Anneke, do you want to add something, or is that all?
No, maybe one thing to add. I think another feature of this framework is also the use of these attributes and the ability, sort of the assessment that we do afterwards using the Shapley value method. And that gives us an indication of what is driving an anomaly. Oh, sorry, yeah, an anomaly basically. And if we know these features, if we know what the key drivers are, we can, we of the operator can start with looking at that key driver first. And at least, I mean, it provides a first toolkit to know what to focus on, and they can look at, because maybe following up on the anomaly of the airport security controls, if indeed someone is flagged and someone needs to be checked, then again the question is what to check. Do I need to check the person, the pockets of the person? Do I need to check the jacket of the person, or maybe the bag? And then I think our method then shows, hey, there's an anomaly probably, and it has something to do with the bag. So then they know, okay, let's first start looking into the bag, because probably it's there. So again, I think that feature also helps helps the employee in finding the proper anomaly and the cause of that.
That's great. And something that I would like to highlight, because of our experience with these kind of models, and I think that perhaps it's something that sometimes we forget to mention, is that in RTGS systems, I mean, the anomaly detection comes afterwards. In retail payments, normally there is anomaly detection, and then you will halt a transaction, you will hold the payment, expect for a confirmation from the user and the end user, or the one who is sending the transaction, and then the transaction goes forward or not. In RTGS, and that's where my question is going, we have that the settlement occurs, and then we do this anomaly detection. Is that right? I mean, that's one key difference from retail payments as well. I mean, I repeat the question. Perhaps I didn't do it right. I mean, is that a difference also because for the methodology as well? Because at the end, what we're doing is post-mortem or afterwards the anomaly detection. I mean, after the settlement has occurred. So that should make everything a little bit different from retail payments, right?
Yeah, no, I think I definitely agree with that. Of course, our framework can be put in prior to the payment settlement when the payment submission, like you can apply all this kind of framework on the payments which are in the queue, but that has a bigger implication because you don't want to delay the high-value payment systems because they are critical and that would delay, as opposed to in the retail payment system, these are small, you might be delayed purchasing something, that's okay, but here it has a legal obligations for many of the payments, right?
Yeah, that's an additional complication. So I'm going to go through
maybe
some of
one thing to add there, because I fully agree. We should not forget that there is, of course, this increase now of the launch of fast payment systems, retail systems, and I think this tool could also be used not only for deferred net settlement retail systems, but also for fast payment systems, processing retail payments. But again, yes, it would then be done after an anomaly after the payment is settled. But again, I mean, then it will still flag potential issues and you can avoid further anomalies to be submitted. But yeah, I think it could also be applied for fast payment systems, which are becoming more popular.
Okay, I think that you already answered some of the questions from the Q&As, which were related to this is for RTGS. Can this be like implemented as well, obviously with some adjustments to fast payment systems? So you already answered that question, so I'm going to cross that out. There's an additional interest from several of our attendees about how did you measure the accuracy of this framework? Because we saw the usual curve of false positives and true positives, but what else? I mean, how else can we check how good the methodology is?
So maybe I can quickly provide some comments on that. So of course, these traditional measures of machine learning model accuracy, you can look. We looked at that, the square, the R2 squares or the other scores. But another thing which helped us to build more confidence on this is when we looked at some of these operational incidences which were labeled in the data set, and we try to see if our model misclassifies those kind of payments. Then we know that when there is a long weekend in Canada, so if the system was closed on Monday, then there are more payments accumulated. So on Tuesday morning, there should be more payments coming into the system. And those payments could be coming on the Monday afternoon, but now they are coming on Tuesday morning. So does model misclassify those payments? So we try to look at some of those systematic examples where we know this is supposed to be happening and is model misclassifying out of sample, those kind of transaction. And then we also manipulated some of the features which we know that model provides importance to them, and will model able to misclassify those transactions afterwards in the out of sample period. So those are some additional measures or additional things we did on top of these usual measures.
Good. Additional question, which is related to, I mean, we're going to address something which is very interesting and that you mentioned, Anneke, which it's about, or it was Ajit perhaps, about centralized data. I mean, if you have all the data centralized, it's obviously easier for any method to try to be trained and to get the anomalies. There are some questions about what happens with the privacy of the transactions. And I was wondering, and I don't want to bias your answer, but I would say that in the RTGS systems, the systems do not have the complete, I mean, the originator and the final beneficiary of the transactions. But in your case, how was privacy protected, or if perhaps there was no threat to privacy? But what do you think?
Anneke, you have anything or?
Yeah, no, I think actually you made a very good point about in this case, the payment system operator of a large value payment system, the beneficiary, the initiator and the beneficiary, they are not the participants in the system. And so what we only see is the transaction submitted by their PSP into the system and the PSP that is receiving that payment. So again, only the flows between the participants of the payment system. The data that we use also did not contain like all the full payment messages. So we actually, we did not have insight into for whom the payment was meant, finally, eventually, or what was the underlying purchase, for example, or the underlying purpose of the payment. That information was not in our data set. And we did not need that data, actually, or that information to run this model. I mean, I can see that if you would sort of replicate this framework for a retail payment system, it might be different. I mean, I know that, but it again depends on the setup of the system. But credit card companies, for example, they might have that information. They might know exactly from who to whom, who is paying to whom, who are the end users, right? And who is maybe and where is this payment initiated? What kind of store? So I think these operators, these examples, well, yeah, these they have more information. But when actually, yeah, when coming back again to the large value payment system, this information is not visible and not available and not needed again to develop this module.
Yeah, just to add one point here is, although customer information is not there, we like in generally high value payment system has a participant like the bank who is a financial institution who is initiating the payment. So we have to even worry about that sensitivity. So we anonymize all those names and other personal information which can pinpoint back to the financial institution before we can put it into the model. So there are ways you can go about that, but I guess when we are talking about the customer sensitivity, that is not part of this, at least not our paper, but there are many ways people can go about it.
Okay, there is a very interesting question, which is a data scientist type of question that I like, which is you showed and you presented in your document what worked. So the question is, which other methods or avenues of feature engineering you found that weren't fruitful and that you left aside before doing this approach?
So yeah, so what we did, so if you are asking about feature engineering, like what a kind of feature engineering we did, so we tried to extract more features than we had, but then when we started to include those features in the training of our supervised learning model, we realized that it is not improving in any dimension. Neither the score or accuracy, nothing has been improved. So we try to remove some of those features. For example, these timestamp features. So we had a lot more than we finally end up having some of those. So we included, discarded some of those features. We also labeled some of the transaction, whether they has any cents, like let's say it's $1,000.10, and some payments which are like a round figure, $1,000. So does that kind of transaction, that kind of information adds the value? So we try to label this, does that has a cent or it's a round figure as another binary feature that didn't add any value. We also try to label some of the loan repayment because we know some of these transactions are driven by this loan repayment. Of course, they are not accurately labeled, but there were some ways people have been used in the past to identify which of these transactions are repayment of the loan. So we try to label those that didn't add value. So we also try to categorize, instead of taking this amount as a continuous feature, if we make it as a more categorical feature, let's say 1,000 to 10,000 is a category 0, 10,000 to 100,000 is category 1. So instead of continuous, we try to discretize it. So we played around this way in a many dimension, but some of these are examples which we had to discard because it didn't play a valuable role in training.
Good. Very interesting question now, which is, are there plans to implement this in the large value payment system of Canada, I mean, Payments Canada, Or do you know any other cases in which there are some anomaly detection implemented in some other RTGSs?
So being part of the research team, our objective is to explore all the opportunities and challenges and put out the policy notes, working paper or research paper out there, and then let the policy team take a lead if they want to use this directly now or in the future, and if they want to use what kind of methods they want to look at. So I don't want to comment if they have a plan or not at the bank at this point. But since we are trying to make it more informative, that there are ways we can use this valuable information we have available at the central level, and that has a value and could help us to add another security layer. Because of course, I guess all the CPMI and other recommendation is to have monitoring tools at the financial institution level. So I guess needs to be additional recommendation coming from all these central banks and other institute to have something at the central level. Then people will definitely start taking notice. I don't know if Anneke has something to add on that.
No, not much. I think maybe yeah. Well, maybe one thing. I think we should not forget that. I think not even central banks, but payment system operators in general, they already do a lot to monitor transactions and to ensure sort of the robustness of their payment systems. And like I said in the beginning, many of those tools are, I mean, they do their job, I think, fairly, but mainly, yeah, based on preset rules. And yeah, we were just exploring, hey, is there a way to do things even better? And especially also now that new systems or systems, maybe some countries are working on new systems, again, fast payment systems, for example, or they're enhancing their existing retail RTGSs. So, I mean, this could be a tool that central banks could explore as they're working on an enhancement of their payments landscape. But I mean, we should not forget that monitoring is already part of their job. But now with new technologies, all these machine learning tools, I think, yeah, what we wanted to do is to see how this can be explored to do things even better.
Yeah. So one point I think you bring up, which I want to highlight a little more, is like, so let's say you have a fast payment system, and in Canada we are working on bringing up the fast payment system, and they need to have a fraud solutions. They have to think about fraud solution as they are designing the system, but they don't have any data. So maybe having this kind of system which is trained or tested and demonstrated on the data which we have, like a good amount of 15-20 years of historical data, then can be transferred to some of the knowledge, or the actual models can be transferred to the payment system where we don't have any data.
That's great. Most of you know that I worked for 16 years at the Central Bank of Colombia in research, mostly in payments. And once when I work on this topic and I found some anomalies, someone told me from the research side, now what? Should we call the operations department? Should we call the payment systems department? I mean, did you find anything interesting? I mean, interesting in the sense of worth mentioning to someone at the payment systems department?
I mean, so some of the things worth mentioning is like there are many things happening. Even if we are not going to take an action in a sense, we should also at least start thinking labeling them, so that we can create the data set for ourselves and payment system provider, so that in the future, if they want to do something like that, they have already labeled it. So you can use this kind of model to label. And maybe there is something which they start taking a look at more closer, as opposed to just labeling them automatically. That could be useful.
Yeah, that's. I think that's mostly the same thing I answered at that time when someone asked me about that. I think that we have covered most of the questions, or all that I think that could contribute to the conversation. So, Anneke, Ajit, thank you very much for joining us today. I don't know if you want to wrap up your presentation with something else. I guess everything has been said. So thank you very much, Anneke and Ajit, for joining us today. It was a very interesting conversation, and I think because of the questions that we have received, I think there are many people interested in reading your document in full, and I think that this type of conversations about how to use anomaly detection not only for retail but also for wholesale on large value payment systems obviously has a lot of interest in the industry of payments. So everyone, thank you for joining us for the payment system broadcast number 17. Thank you, Anneke. Thank you, Ajit, for joining us. And the upcoming events, it's on the right of this slide, in which we're going to have during November and December, several payment system broadcasts, a CBDC broadcast, and a consumer fraud and scam broadcast. So thank you once again for joining us, and we expect to see you soon in our following events. Thank you, everyone.
Thank you, Carlos, for hosting us. It was a pleasure.